I think we can start. Everybody's here. Okay, good morning. Thank you for coming. It will be a double speech, not double in time, but with two parts. We will show you the Eclipse IoT technologies in action and trying to show you a near real-world application that we built. So for my part, I will start with a collection of data on the field. I am more speaking on Cura and all the part of the sensors and data collection. And Pierre here will speak about analytics and intelligence from the data. So an Internet of Things application is more or less built from four main parts, we will say. The first part is the most important thing is the data. So the data must be collected and must be integrated from the field. This is done generally from gateway. The gateways can be very small, like this one. It's a Raspberry Pi, which is an open source board. Can be more strong boards, like we are building Atom boards and these kind of things. Or you can have also intelligent sensors that are inside the sensor, the software stack that is able to collect and integrate the data from the field. When the data are collected, after you have to send the data somewhere because there is somewhere a system, a command control system that needs the data. So we will use for this application the Mqtt protocol, and we will use the Paro client, which is also an Eclipse project. And when the data are sent, it's at the other side there is a broker, an Mqtt broker, and in this case also we use an Eclipse open source broker, which is Mqtt, which is a Mqtt broker that you can find in Eclipse. And finally, the data are analyzed and the intelligence is taken from the data. This is the bird part that my colleague will speak about. And the fourth part is we will not speak too much about that. It's the management of the devices on the field. And this is also done through functionalities in Cura. So we will speak after that from Cura itself. So the real-world application that we are showing is not this one, in fact. This one has been made in EclipseCON in San Francisco. We didn't do the same here. It was too short and we are not enough to do that. In San Francisco, the passenger counter that you can see in the hall has been installed in all the doors of the main ballroom. And in real time, people were counting inside and outside. And the goal of that was to be able to say, at this time, there is so many people in this room and so not so much in this other room. So you can be able to say, okay, this talk is very interesting. There is many people in this talk, but this one is a bit less interesting maybe. And you can see people flowing also. So in real time, you can see the curve of the people coming in and coming out. So this is one of the application of this kind of sensor, passenger counter is, well, we call it passenger because initially it was made for bus and transportation to count people inside the buses or trains or to make some statistics or to detect the fraud or this kind of application. And there is another sensor that you can see also in the hall. It is an environmental sensor that we could call an intelligent sensor because the sensor integrated the gateway. For the passenger counter, gateway is outside. It's in this case it was a Raspberry Pi gateway. Environmental sensors is analyzing the most common pollutant and electromagnetism and these kind of things. And also in real time, this is sent to a server somewhere, and the data are available to be, after that, to be analyzed and to get some intelligence from that. So this is the real-world application. So just to show you how it was done, the sensors were on tension rows at each doors. And now we will see what is the flow of the data. So the architecture is made first, as I told you, from the data collection. So the data collection is made from the sensors, and inside the sensor or in the gateway, you have a software stack that we call Cura. It is a new Eclipse project that has been published a few months ago. You can find it in Eclipse now. Cura has firstly been developed by Eurotech, the company where I am working. Eurotech is historically a hardware manufacturer. We are in M2M business for a long time, and M2M evolved to IoT, and we became also software manufacturer. So we built a stack that we needed for our devices, and we decided to give this stack to the open source community through Eclipse Foundation, and his name now is Cura. So Cura is a software framework for IoT, for gateways working in IoT. Gateways is the edge controller that is getting the sensor information and sending it to a server. We will see Cura after that. And so the data are sent through an Mqtt connection to a broker, as I told you. And on the other part, the actuate part, which is taking the data for BERT, for analysis, is also getting in. It can be a direct connection from the gateway to the BERT analysis, but we are here using a cloud server in the middle that is storing data. This is useful for historical analysis, for example, and these kind of things. And BERT is making some nice report after that. Just a small word about the sensor. So the people counter sensor is in fact a stereoscopic. There are two cameras that are very specific, that are analysis infrared shadows like that, and just detecting a cone in stereoscopy that give how I could say, to make sure that there is a person inside, not a case or a dog. Or this is discriminating the persons, and it is able to count many people going through the door at the same time. It's quite accurate. We say it's 97% accurate for what we can know now. And there are many systems in the world using this now. So this is a sensor for the people. For environmental monitoring, so we have a three-part sensor. One is for the air quality, the other one is for electromagnetic and the connectivity at the top. So also all these sensors are sending data through whatever they can find. It is 3G, Wi-Fi, Ethernet, GPRS. So this is the basic communication of all this system. The Cura gateway. Cura has been made for developers' productivity. So it means that it's a Java OSGI-based system. So it means that everything that has been developed on this system can be reused on other systems without any modification. If you have a system with a Java machine able to run an OSGI, it will be able to run Cura. So this is just after that an hardware adaptation of all the hardware abstraction layer. This is very modular. This is using OSGI declarative service. So the bundles are able to communicate, are configurable through the declarative service, And it's very easy to update, remove, add some bundles. The device abstraction is total. We made a full device abstraction layer, so you don't have to care all of the communication part, of the I/O, and all the management of the system. And this is also, there is a high portability for the application. So for the developer's experience, it's quite easy. You can start developing your IoT application on your laptop under Eclipse. There is a full Eclipse integration. This is pure Java. You have an emulator in Cura that gives you the ability to test your bundles on your laptop. When you are done with your development, you can deploy it on the target. So there are tools to deploy the system on the target. The target can be a small Raspberry Pi that you bought $20 and you have it on your desktop. And when the system is really ready, you can deploy it on the field with the hardware that you've chosen. And you can provision and update, upgrade, configure every device through the management layer that is inside Cura. It is all embedded in Cura. And there is a small web server in Cura that gives you the ability to connect locally to your device and to do whatever you need on the device for configuration and management. So Cura a little bit more in depth. So as you can see, the layers, so Java VM, OSGI, the device abstraction layer, we will see after that. Gateway basic service, field protocols. The administration GUI is a web server, and connectivity and management. So inside, we reuse some already existing open source bricks that we didn't need to reinvent. So on the device abstraction, for example, you can see that for the serial communication, we use the JavaXCOM brick. For USB, it's a JavaX USB. And we have also a position which is using the GPS bricks that exist in open source. The basic service are integrating a clock service for timestamp, a watchdog, which is something very specific to Cura. So you can declare that one of your bundle is critical to the watchdog, and if the bundle fails, the board will restart. So this is also a new functionality. The field protocols can be extended. For the moment, we are just showing you the two field protocols that we are using here in the demo. It is the protocol for the people counter and the the environmental sensors. Connectivity is full also through cloud service. We have a Mqtt client based on Paro that will send data through Mqtt to a server, to a broker. We have a data service which is storing data, can be locally or can be stored on the cloud. And we have cloud services to manage the connection with the cloud. The remote management is an important part of Cura also, so you can manage your device through Mqtt. This is also a very new application, and on the top, your application that you will develop after that. So this is just some screenshot of the small web server that is inside, that give you the ability to administrate it through a UI. And at the end, so the data are sent through Mqtt. They are using topics, and we are using Mqtt to send the data through a payload integrating all the metrics. Rather than sending one topic per metrics, there is a payload that we defined, and inside the payload you have all the metrics that you need for your application. Then after that, these data are stored on our cloud server or sent on a broker that can be used on another way. And after that, it will be the part of Pierre that will explain you what he is doing with the data.
Thank you, Pierre. So, first of all, quick word from the sponsor. I promise it will be just a few slides, and then I will show you how actually we use BERT to get to the data and then create a dashboard. So if you've been through the booth, which is at the this end, that other end of the hall, you've seen the portal. Everybody is scared of going through the portal, by the way. They make sure that they go around, but it's important to go through so that we can count you. And we capture the data and we display this dashboard, which is on the screen. The dashboard is actually created with the Actuate or BERT technology. So what is BERT? Who knows BERT in the room? Very good. Okay, so I'll be very quick because I have a session at 1, my little plug for my session, which I will go through the whole BERT project. But BERT stands for Business Intelligence and Reporting Tool. And as I said this morning in my pitch, this sounds very boring. Business intelligence, that's financial stuff. Now you see we can connect also to things. We can connect to data that's like not your regular type of data that you think of when you build a report or a dashboard. So we started the project in 2004. I say we is Actuate. Actuate is a American-based company. We've been in the BI business for 20 years. So 2004 is about 10 years ago that we initiated the project. We went to Eclipse and said like, hey, we want to go open source. We want to have a new project, and we'll call it BERT. So it's a new generation of embeddable reporting and analytics. What does that mean? It means that we can take data from everywhere, and I'll show that in the quick demo. We can build reports, we can build visualizations, we can display them anywhere you want. We can display them in just a straight viewer, in an HTML page, in a mobile device. So that's the idea behind BERT. We're very open, standard-based, JavaScript, Java, CSS to build your stuff. We support reuse of libraries. That's very important. When you build something and you build like 100 reports and you have a logo in the top right corner, and then all of a sudden you change the logo, you don't go and change 100 reports, you change the library. That's clever. Okay, so that's BERT for its what it means. High-level architecture, and again, I'll go through that a bit more in detail this afternoon. There's a designer. I'll show you the designer today. And in open source, there's a BERT engine. Now, the engine you have to embed, of course. It's a jar file. You put it in your application server. You can create Java around it. You can create your own server, in a sense. There's also a commercial release. Commercial release is where Actuate comes in. We do the integration of the BERT engine into a server that has all the functionality of a high-end BI system, which means we'll take care of the security, we'll take care of creating batch reports, we'll take care of archiving, having different versions. Stuff that you can do yourself, but you'll have to code and code and code and code and code. Okay, so that's the commercial release. And again, this afternoon we'll go through that in more detail. So what do we do with this? Well, we create data visualizations. Now, the left side of the slide has kind of like the different types of data sources we can look at. And notice that it doesn't even say, or it's very hidden here that we have like SQL type databases. Now we do connect, of course, through the JDBC, but we can connect also to very, very different types of data sources. And I'll show that actually in the example, because the type of data that's coming from Eurotech is a type of data that's a bit exotic and that we can connect to. And then we embed in the application. So the commercial release, which is actually called BERT iHub, is where we embed the BERT engine, and we can do the batch, the planning of the reports, the versioning, etc., and create also data objects, which are storage areas where we can take the data. So, in a nutshell, what do we do with the data? How is this built, the application today? So, Pierre has shown you the data acquisition part, from the sensors, from the portal, etc. It's stored on a server. Actuate comes in with the BERT iHub. So what we've done here is that we're actually connecting to the server, the Cura server, and we're getting through web services the data. So I'll show you that I have written a little Java class here to actually get the data. Then we use the BERT designer to create the visualizations. So the charts, the tables, etc., that will actually be displayed in our dashboard. So that's the designer part. And it creates a report design. So it creates a web report. Now, we also have the concept of a data object. The data object is actually a connection to your data, a bunch of data sets, a model of the data that you can use in other reports. And that's what we've done here. And I'm doing it for the historical data. So we can go back in time, count how many people have been through the portal, see the fluctuation of the temperature, the humidity, etc. in the room. So we can store that in the BERT data object, and the web report will actually get its data from there. And we can finally display it through a dashboard, a mobile device. We could print it if we wanted to as well. So that's, in a nutshell, the architecture. I think I'm going to go now to the actual demo. Oh, there it is. Okay. All right. So how does this work? So there's the first thing is to get to the data, to get to the data that's provided by Eurotech. So I'm showing you here the two main classes that I have written. One is just a description of the data, just a class that will give me all the columns that I need in order to create my report. So it's just a bunch of getters and setters to actually set to create that data set. The second one, the Eurotech data set, is where I will connect to the Eurotech data. So it's a straight Java class. I can actually run it. If I go here and I run it, I can just now connect to the Eurotech server and get the last 100 rows of that data, which are just shown here at the bottom. Okay, so I'm just passing a URL, getting the data, etc. Now, how am I going to connect to that through a BERT report is through a data source. So let's take a look now at the data design. And for this, I'm going to now switch to the report design perspective in Eclipse. So the report design perspective is where you create your BERT content. BERT content can be a data design, can be a report design, a library. This is where you actually create your visualizations. So the first thing I did was to create a data source. I'm going to connect to that data that's in Eurotech. Let's take a look at the different data sources that are available in BERT. Now, this is the commercial release. In open source, the list is a bit shorter, okay, but it's quite impressive nevertheless. So what I'm using here to connect to the data is the POJO data source, what we call also the Swiss Army knife of the connectors. It means that with a POJO, I can connect to any type of sources that I have written through a Java class. You just have to understand what are the main classes or methods that you need to create, but that's basic stuff you have to know. So what does it look like, my data source? It simply points to the jar files that are needed to connect to the Eurotech data sources. And then the data sets, I actually have two here. I have one for my environmental data and one for the population data. And the reason I have two here is quite simple, is because the data was stored in two different servers. When we did the demo in San Francisco, it was actually one data set was needed. Here I have two. So in the data set, I simply call the class I've shown you a few minutes ago, which will actually connect to the Eurotech. And then I map the data to the other class that actually has my getters and setters. It's as simple as that. Now, I could make this easier by being a bit more complicated. Huh? What I mean by that is I could also write an ODA, Open Data Access. I could write my own connector, would call it the Eurotech connector, that embeds all this into a nice UI for designs and a nice UI for, or not a UI, but a runtime engine. And that exists. If I go back here to my data sources, those exist, for example, for MongoDB. So I have a connector here for MongoDB, which is actually an ODA that's been written by the open source community. So connecting to MongoDB could be done through the Pojo, or could be done by an ODA if I write the ODA. Okay? Very important concept here of showing the openness of the tool to connect to different data sources. If you know it's going to be just a one-shot thing, then you just use a Pojo. If you know that it's going to be more, it's going to be used more and more, then you write the ODA. Okay, so I have my data design, my data object. So I've connected to my sources. I'm getting my data. And I can look here at environmental data set, preview the results. Now it's connecting through to that server, and it's going to give me the first 500 rows of the data from Eurotech. And it's quite live, as you see, like 11:31, which gives me I have 2 minutes to go. But I'm almost done. So the final step is to write that nice dashboard that you can see on the screen in our booth. So writing the dashboard is simply using the interface, the graphical interface of BERT, of the report design perspective, connect to the data object this time, and get the data that I need through data sets. And after that, well, I can create charts. I have nice wizards to create charts. If you're in open source, or I should say if you're in the commercial release, then you have HTML5 charts, which are quite flexible. You can add some script if you want. And you can also display, of course, the data by itself. So how does this work in the commercial release? So we can publish then the data object. So I have a data object here in a folder. I have here the Eurotech Toulouse, which is the data object I've created, which actually gets the data, and it's been put on a schedule. So if I go here to my jobs, schedules, you see that it's coming, and the next one will be in 2 minutes, 11:35. And then when it's completed, it gives me a message saying, yeah, it's been good. So that data object is refreshed every 10 minutes. And the end result is showing the report. And I'm showing here the report in an HTML page. I could use just the basic viewer of Actuate, but here what I've done is embed the report in an HTML page. And we do that through some JavaScript integration, very easy type of integration. So that's in a nutshell how we can connect to the Eurotech data. We can connect to data that's IoT. We can connect to any type of data through the openness of the data access. Okay, thank you very much.